So, welcome back. In the last lecture, which was the first in the series of the lectures on waves, we discussed waves. We categorized them into three categories. One, where we have the mechanical waves, which is material waves, which need a medium for their propagation. Second was the electromagnetic waves, light and infrared and ultraviolet and X-rays, etc., etc., etc. And the third set was that of matter waves, which involved quantum mechanics rather than the classical mechanics. I gave you a reference to that and then explained to you that the waves are transverse or longitudinal. Okay. Now today we will talk about progressive or traveling mechanical waves. Okay, this can also be the equation that we search here is as to what is y x comma t, where y is the right now we will talk about the transverse waves which are traveling in the positive x direction, and there the vibrations that take place at any location are transverse. Now, well, the positive x direction, if the motion is there in the positive x direction, then y x comma t is taken as small a cos of kx minus omega t plus phi. And the negative x direction, instead of this minus sign over here, this becomes kx plus omega t plus phi with a as the amplitude. Well, we start with the wave equation, okay, the one in the positive x direction, and we consider for the time being that we are talking about the transverse waves in medium. Okay. Now, actually, if you look at this, then this yx comma t is actually equal to a cos of theta, where I'll write this theta is equal to kx minus omega t plus phi as it is. So look here, what is theta? Theta is an angle, and this angle is in radians. Remember that we are not talking about the degrees. Whenever we talk about the theta, and what is theta? If we travel anti-clockwise, then theta is arc upon radius. So it is a dimensionless quantity, and of course radians is given as one of the things historically as one of the units. Otherwise, well, anyway, the units are radians and degrees, etc., etc. So now, what should be the dimension of kx? Where x is the length, this should be dimensionless. Therefore, k must be equal to 1 upon length. What should be the dimension of omega? Omega should have the dimensions of 1 upon t, and this is of course a constant angle. Okay, so we have this defined like this. Now actually we are going in explaining this thing in the reverse order. I would have loved to establish this equation for y is equal to x comma t in this form or in this form, and that I will do later on. Okay, first of all I will explain to you what is the equation with progressive or traveling wave. Okay, so I can write now, taking the cue from what we have done before, I will write this as equal to a sine of omega t kx minus omega t plus b cos of kx minus omega t. And then we take a right angle triangle, okay, and define by phi like this. So this is A, the hypotenuse, and the perpendicular B is equal to A sine of phi, and the base A is equal to A cos of phi. So I can write A square is equal to capital A square plus capital B square. And tan of phi, I can write it as B upon A, and so that the phi is arc tan of B upon A, or tan inverse of B upon A. Okay. Now let us try to analyze this equation. And the first condition that we take is, let's see as to how a particle along the line of propagation, it oscillates with time. So what I do is, I take the value of x over here is equal to x naught, a definite value, some constant, chosen randomly, okay, doesn't matter where this x naught is located. So the location I have fixed, and then if I take the q from this equation here, y x comma t is equal to this, I will write y is equal to x naught t is equal to a cos of minus omega t plus kx naught plus phi. I have just made some changes, which I can write as a cos, and because you know cos of minus a is equal to how much? Minus cos a. Because cos or cosine is a symmetric function. Sine is asymmetric. Okay, the sine of minus a is equal to, I'm sorry, this is cos of minus a is equal to cos of a, but sine of minus a is equal to minus sine of a. Okay, slips. Okay, so what I write it as the equation, a cos of omega t minus alpha, where alpha is taken as equal to kx naught plus phi. Phi is defined, x naught is defined, k is defined, so alpha will also be defined. It will have a certain value, and I don't care what value it is. Anyway, so I have got the equation of yx comma t is equal to a cos of omega t minus alpha. Let us try to plot this as a function of omega t. Also you can plot it as a function of time t. Okay. No problem. So it is a sinusoid kind of curve which is happening, and I have taken a certain accommodating the value of alpha. I have here the y-axis, and origin is over here, and thereafter you can see that the oscillations are taking place. Of course this is in the negative sign, so it doesn't matter. Now that means we have a simple harmonic motion. Okay, the particle is oscillating in the simple harmonic motion, just like a pendulum, just like a spring. Okay, with a mass attached. So this SHM that we have, it has an amplitude A with properties of omega, nu and t as we know. Okay, and minus alpha is equal to minus kx naught plus phi, which is the initial phase for this thing. You can see that this alpha, because phi is already defined over here, k is already defined over here. K is called the wave number. The wave number, the number of waves that you have in a unit lambda. Okay, wavelength. Okay, so I have these things. You can see that this alpha is dependent on our choice of x naught, nothing else. So if you change this to 2x naught, then this minus alpha will become equal to minus k into 2x naught plus phi, etc. Okay, and next we take as to what happens if t is taken as equal to a definite time. So let us, instead of making x as a constant, let us take a look at what happens when the t is fixed to a definite time or any definite time t naught. What will happen to our equation? The equation of the travelling wave, y x comma t naught will become equal to a cos of kx minus omega t naught plus phi. Okay? Simple. Now, phi is known to us, omega is known to us, t naught is known to us, so this becomes a constant. So I can write this as a cos of kx plus beta. I can take any value ka kha ga ga anga. Okay. A B C D E F G alpha beta gamma delta. Okay. Alif ba ta sa, anything, any symbol. So this beta is equal to minus omega t naught plus phi. Okay. Now this is the equation which is an oscillating equation in the value of x. Okay. X is this direction. So if I plot this y x comma t naught equal to a cos of kx plus beta, what I will get? I have exaggerated it, but if it is happening in a string, the wave is travelling along the positive x direction, then I will get something like this. And I have just put the zero of this axis at a random point, which defines, of course, our value of beta. Okay. So you can see what I've made over here is that from this point to this point, the length of the string which is vibrating, I've taken it as equal to lambda. And this is a kind of a snapshot at t is equal to t0. I've just clicked it, taken a photograph, a still photograph. Okay, and that photograph of the string which is vibrating looks something like this. Okay, of course we can go like this and this and this. If the string is long enough and the wave is progressing without any energy diminishing for the wave. So under the very ideal conditions we have like this. Now lambda is called the wave length. Okay, and this has a relation with the frequency. Lambda nu is equal to the velocity, the speed by which the wave is progressing, etc., etc. Let me find out as to what is the value of k lambda. So here I substitute lambda. What I get? 2 pi upon lambda. This is the k, value of k, which I have written over here. Okay, 2 pi of O lambda. And what is this called? The wave number, the angular wave number. When I multiply it, lambda and lambda cancel out and we get 2 pi. Okay, so this is a spatial graph, y versus x, where I have just taken a snapshot, I have just taken a still photograph at that instant of time, which we call t naught, which can be anything. We find that, like before, where I had the value of alpha, this beta is equal to minus omega t naught plus phi, and this definitely depends upon the value of the choice of t naught. Okay, so if we take successive photographs, then we will get the successive snaps of the string which is keeping on vibrating in the progression of the wave, in the traveling of the mechanical waves in the positive x direction. Now, remember, in the previous equation which we had, when we took x is equal to x naught, we obtained the relation as a cos of omega t minus alpha. Okay. If I keep it omega into t, and because omega is defined as 2 pi upon t, so multiplied by t, and what I get is 2 pi. 2 pi. So the wavelengths occur one after the other at the angle interval of 2 pi, 4 pi, 6 pi. That means an even number of pi's, whether it is here or whether it is in this situation. Okay. Now 2 pi is in the angle, in the case that we took this as a cos of theta, 2 pi indicates periodicity. This 2 pi, so cos of theta plus 2 pi, cos of theta plus 4 pi, cos of theta plus, or anything if it is a sine function, then sine of theta plus minus 2 pi plus minus another 2 pi plus minus another 2 pi, and there is a periodicity. Okay. So friends, you have learnt about the amplitude of vibration which I have shown over here. You have learnt about the frequency which I have shown over here. You have learnt about the time period which I have shown over here. You have learnt about the k, which is the wave number over here, lambda, which is the repetitive thing in the case of the space diagram, space to space diagram, that is y versus x diagram, which is a snapshot always. And similarly, we can talk about this wave here, the wave propagation in the negative x direction. I leave it to you as an exercise, and in similar fashion we can talk about the longitudinal wave in a certain direction. Okay, we'll talk more about these things, their how they encounter rigid bodies, how they encounter the obstructions, etc., etc., and how these waves can, of course, what I have not done is to be done by you, that you take various values. I have taken this at a value t naught, okay, and this at a value of x naught. Now you can have x as lambda by 4, 2 lambda by 4, 3 lambda by 4, 4 lambda by 4, r lambda by 8, 2 lambda by 8, etc., etc., and make the plots if you like, and you will understand how things change. I'm not supposed to tell you all these finer details, okay, because that is something boring. Okay, and similarly, in this case, you can take for t naught, you can take t by 8, 2t by 8, 3t by 8, 4t by 8, etc., etc., and see as to how the strings which are vibrating, they are located. Or in the case of longitudinal vibrations, where is the center of the compression and where is the center of rarefaction and how it travels, that all you can do with the little bit of explanation that we have. And before I end up this chapter and this 11th class course, of course I will tell you how the transverse and how the equations, these equations can be obtained, and I will show to you that I will not say that it can be easily shown that this is equal to this and this is equal to this. No, I will show you. Maybe it's not easily shown, but definitely shown how this kind of equation is obtained. There is another thing, okay, we can talk about from these as to what is the wave velocity, and we can show to you that because velocity is x upon time, so I can say that velocity square is d2x upon dy, dy upon d2x, dy upon dt2 divided by dy d2y over dt2 divided by d2y upon dx2. That will follow and will come up in the next lecture shortly. So thank you very much.